0, and starts now. 4, 0, 0, 4, 6, 6, 3, 0, 8. And that is my student number. And this is our overall circuit. This is actually the second time we built it, because the first time, although I worked, we just wanted to make it neater and make it actually color-coded. So this is our second time making the circuit.
All right, so for the color coding of our circuit, we have red for power and black for ground, and everything that's in yellow is represented for clock.
Yeah, so like the flip-flops are clocked, the flip-flops are clocked, and the converter over here is also connected up to clock.
And everything that's in blue is intermediate logic that we have between our gates. And then everything that is green is related to our Q outputs for each.
Yeah, and then you can see that we connect up the greens from the flip-flops that go into the converter. The converter goes into the 7-second display. And this is the actual layout of the flip-flops and ICs on the board right now. So we have at the top we have three different flip-flops, and we have 4 different gates. So we have 1, 2, 3, 4, 5, 6. That's how we have the flip-flops labeled. We have 1, 2, 3, 4, 5, 6, and these 2 are the actual counter flip-flops, and these 4 are actually responsible for the actual counting of the bits. And then over here we just have and, or, and XOR. And, or, XOR. Those are the 4 gates. And the converter over there. And we had the choice of actually doing either more OR and AND gates but no XOR gates, or just reducing the number of gates but adding another chip. It actually turns out that both ways used up the same amount of chips really, but the second version actually used less gates overall, so we just ended up using the second version then. And
for errors and issues?
Yeah, issues that we had.
One of the main issues we had was a faulty equipment for our connectors, where the connection from the clock would cause the 7-segment display to, I guess, just
go haywire.
Yeah.
And we just used a different connection, and it just started to work. So.
And another issue we ran into were when we tried to implement LEDs into our outputs, and the resistors we used were, I guess, too high to the point where the LED outputs was very minimal. So we had to change the resistors we used. And
for the testing purposes.
Finally, we had an issue with just one of our logic gates that was incorrect. And we corrected that pretty easily.
Yeah. So overall, it wasn't too bad, but thankfully, it now works. And that is our project.